All right, AP Stats studier people, here's a quick review from Chapter 16. The OC's go-to for their pets has an average bill of $120 for cats and $100 for dogs. So I'm going to call that an average, $120 for cats, a mean for dogs for 100, standard deviations, 25 for cats and 35 for dogs. Find the expected value and standard deviation of a person who takes in a dog and a cat. So means simply add. They're as easy as you want them to be. So 120 plus 100, we expect the bill to be 220. Standard deviations don't simply add, but their variances do. So square root of 120, that's wrong. 25 squared plus 35 squared. I'm not going to go through the calculator. I trust you can push buttons. That's about 4301. The OCs have 3 cats. True. What is the expected value and standard deviation of taking in all 3 for a checkup? 120 for the first cat, 120 for the second, 120 for the third, or 360. Should also say for the 3 cats. Standard deviation for the 3 cats would be 25 squared, 25 squared, 25 squared. Yes, you can rewrite that as 3 times 25 squared. That should be about 43.3. C is where it's at. What's the probability that the cost to take a dog to a vet is going to be more expensive than a cat? Remember, we expect the dog to be 100 and the cat to be 120. So we're usually going to think that the cat is going to be the more expensive one, high maintenance. But what we're going to do is build it like this. Probability that the dog is more expensive than the cat. Do a little algebra. So dog minus cat is going to be greater than 0. What we're doing here is finding the mean for dog minus cat, so I can draw it all out. Dog minus cat, we expect the dog to be $20 cheaper, but there's some standard deviations involved. And that we actually already got up here because the standard deviation of cat plus dog is the same thing as the standard deviation of dog minus cat or cat minus dog. The formula doesn't change. 4301. All right, so now I didn't say it in the problem, but we know we can use a normal model here where we expect negative 20, but the standard deviation is pretty large. So one standard deviation above is right about 23 positive. And we know that somewhere in there is going to be our 0. We want to know when this whole distribution or the differences between dogs and cats, we expect the dog to be $20 cheaper, but sometimes the dog is more expensive. So we want to find this probability, judging by that sign, and go to the calculator, normal CDF. The low bound, the lowest area in the shaded region is 0. And since it goes off to infinity, we just need an artificially huge number. Mean, negative 20, standard deviation, 4301. I'm going to trust you know how to press some buttons. That should be right about 32%. All right, moving on. So, Mr. OC gets sent memes from his students sometimes. True. Here's the amount of memes sent to him per week and their probabilities. So expected value and standard deviation are actually really long formulas. What I would expect you to do is probably do this on the calculator, and that is on this sheet. So we'll go memes, 0, 1, 2, 3, 4. And then 52, 12, 10, 1808. Now you can abbreviate that something shorter to find the mean and standard deviation. Statistics, stat calc, one variable. First one should be the outcomes, means, and frequency list is what you have to change to probability. Everything else, don't really care about. Hit OK. Here, have the expected value mean, and down here is where your standard deviation is going to be. So 1.18, you really probably use mu instead of x bar on that. But same deal, standard deviation, 142. Last one, down here, find the mean and standard deviation of each random variable. So some of these different than others. So 4 times x, 4 times random variable x would just be 4 times that 15 right here is 60. And standard deviation, 4 times 3 is 12. Because both of these are affected by multiplication of a constant. All right, we have to change it up just a little bit for adding a constant. Random variable x plus 200. Mean still works like you want it to. 15 plus 200 is the 215. Standard deviation is not affected by adding a constant. We're keeping it at 3. Remember, standard deviation is measuring spread. So if you add 200 to everything in a data set, it's going to be the same amount of spread out. C kind of combines the two, actually totally combines the two, A and B. Mean is as easy as you want it to be. So 4 times 16 plus 200 is 260. And standard deviation, remember, we don't care about adding the constant. It's just going to be the same as A. 4 times 3, standard deviation is 12. Now, D change the story because we're combining two random variables. Mean, basic, 28 and 15, last time I checked, is blah, 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 43. Standard deviation works a little bit differently. But we saw this on the front page, actually. 3 squared plus 7 squared is going to be 762. E, same-ish, 28 minus the 15. I'm sorry, my bad. Reverse that around. 15 minus 28, negative 13. Standard deviation is the same. We do not change that. F, y1 plus y2, same deal. 28 plus 28 is 56. And standard deviation, same 1 squared. So 7 squared plus 7 squared is about 9.9. And then G, mean should be basic. 5 times 15 plus 2 times 28 is 131. Standard deviation, this is a little bit different. You have to remember that it's going to go 5 squared, 3 squared, plus 2 squared, 7 squared. This is coming from this. This is coming from this. Whereas our actual standard deviations or variances are coming from up here. And that was 20.52. All right, and I only have a couple seconds, so I paused it and I wrote out the same stuff for H. It's exactly what the means, same what it was before, added 30, but you don't add 30 to the standard deviation. It's the same. Peace out.